What we're looking at in this video is a thing called the CPU, or the Central Processing Unit. So the CPU. And an example of a CPU and what it looks like is this. So this is the pins underneath that fit into a motherboard, and the CPU's actually on the reverse side, and it will look like a small piece of metal. That's actually a cover for what is a very smaller piece of silicon which has the CPU on it. Normally what happens, this gets flipped over, placed onto a motherboard, and on top of it what you have is this thing here, which is known as a heatsink. And there's different better designs to this. So the idea is that in these fins, the heat from the CPU goes through this thermal gel, and then it comes up through the metal and gets cooler because of the metal fins. And onto the top of these you can also fit a fan, and so this dissipates or gets rid of the heat from the heatsink, and through the thermal gel that cools down the CPU itself. So if we move on a little bit from that, what we want to look at is how this CPU works, and we'll look on a more general level than the internals of what's going on underneath it. So first of all, what is the purpose? What's the point of the CPU? What it does is it executes instructions. So within an algorithm or a set of instructions, I tell the computer what to do, and one by one the CPU executes those instructions, or it processes the data by executing instructions. And you can think of it like the brains of the computer, the thing that actually does the work. Inside it, it's dealing with arithmetic, and there's a part of the CPU called the arithmetic logic unit, and it's also dealing with logical operations, and it's dealing with inputs, and it's dealing with outputs. Essentially, it's just processing command by command. Now, there are a number of things which affect a CPU's performance. So the first very obvious thing that people think about when they look at CPUs is the clock speed. And the way that we measure the clock speed is in a thing called hertz. And this is the number of instructions which this processor can do in 1 second. So if this processor was a 1 hertz processor, it would be doing 1 instruction per second. So 1 hertz equals 1 instruction per second. If it's a 16 hertz processor, 16 instructions per second. Now that's actually really, really slow, because the instructions it's doing are really simple instructions. It might be just adding 2 numbers together. It might be subtracting 2 numbers. So we actually go much faster. 1 kilohertz would be equal to 1000 instructions per second, and 1 megahertz would be equal to 1 million instructions per second. And let's just go up here. 1 gigahertz is equal to 1 billion instructions per second, so 1 billion hertz. So it's incredibly, incredibly fast. If we then look at some real processors and how fast they are, we can look at, for example, the Xbox 360. So this processor has 3.2 gigahertz as its clock speed. So it's able to execute 3,200,000,000 instructions in just 1 second. The Samsung Galaxy S3 is a processor which operates at 1.4 gigahertz, so a bit slower, just under half the speed, and it's able to execute 1.4 billion calculations in 1 second, which for a mobile phone is pretty fast. Now there's a little bit more to this. More recently, they've realized that upping the speed of these processors is actually getting really, really difficult. So what they've decided to do is to make multiple core processors. So we also have something called multiple cores. And what this happens to do is it runs instructions at the same time as each other, and so they run in parallel. So two instructions are happening at the same time. So the Xbox 360 is not just a 3.2 gigahertz processor, it's also got 3 cores to it. So it's able to run at its peak 3 times 3.2, which would be 9.6 billion instructions per second. Now, it will often be much slower than that because it can't use those processors perfectly in parallel. However, that's the potential for that processor. In the case of the Samsung Galaxy S3, it's a quad-core processor, which means that it has 4 cores. So even though it has more cores than the Xbox 360, it's running at a much slower clock speed. And so here we've got 4 times 1.4, which is equivalent to 5.6 billion instructions per second. So that's 4 times 1.4. So essentially what you're saying is, if I increase, and this is the general thing which you need to know, if I increase the clock speed, then the processor executes my programs faster. And it's exactly the same with the number of cores. If I increase my number of cores, then my program can be executed faster. And that does rely on the programmer being able to use both of those cores at the same time. Now, there's one extra little bit to the problem which we need to look at. So if we look at the processor design at the moment, what we have is a core, and there's another part to it which we'll come to, and that makes up my CPU, and I'm able to put inputs into that, and I'm able to get outputs out from it. So this will be controlling using my input devices and then sending the information to my output devices. It's also able to talk to, get information from, and put information to storage devices. And my CPU is able to read and write from memory, which typically is going to be RAM. So inside, this is a 1-core processor. And on top of that, I've also got something which is called cache. Now this is just like RAM. There's no real difference between RAM and cache. The difference is, though, that it sits right beside the processor. So it takes almost no time to get from the core into the cache and back out again. Now, it doesn't store very much memory. It's a very small amount of storage, but it's very close to the core and it's very, very fast. And so if you have a large amount of cache on a processor, that's going to speed up the processor as well. If it has to go all the way into RAM, RAM tends to be quite slow and it tends to be far away from the processor, so that's going to take a lot longer for big programs that need a lot of processing of data. The design only changes slightly, so the only difference on the design with a multi-core processor is that instead of having it where you've got 1 core underneath, all that's going to happen is that you are going to have 1 core and then you're going to have a 2nd, 3rd, 4th core. So this is a dual core, 2-core processor, and then sitting above that you're going to have your cache sitting there. And so that's all that's happening when you have more cores on your processor, and all of that will be on the same chip, and that will be part of the CPU. So if you had a quad core, 4 cores, there'd be 4 cores sitting down here, a cache above, and that would make up your CPU.